When you have a cyclic diene reacting with a dienophile, it's possible to have two kinds of what we call Diels-Alder adducts. Now the Diels-Alder reaction is the same as what we've been looking at, and these would be the C's at the end of the diene, and these are the C's at the end of the dienophile. So you can see that what's going to happen is we're joining this C at the end of the diene to this C at the end of the dienophile, and this C at the end of the dienophile to this C at the diene. So we end up with this kind of product where we end up with a double bond here and new bonds between here and here. Now the two ways that we can add are called endo and exo. The endo one is the one I'm going to show you first, and here is a 3D animation of it. So let's take a look at how this happens. Now if you'll notice, you'll see that we've got this diene double bonds here. I'll slow this down a bit. You've got the diene double bonds here. We've got the dienophile double bond here. And what makes it endo is the fact that the C double bond O's here are actually close to the new double bond that's forming over here. Okay, there's our new double bond there. And there is the join from this carbon of the dienophile to this carbon. To this carbon of the dienophile to this carbon of the diene. So just to sort of orient you a little bit about where we're at with this adduct here, you can see this C here and this C here were the C's that made up the end of the diene, this carbon here and this carbon here. And you can see these two carbons here are the carbons that made up the dienophile. And that's these two carbons right here. Alright, let's go back to the thing, and you can see how this is adding. You can see that the C double bond O's are pointing to where the double bonds from the diene are. This is what makes it endo. And it's called endo because the dienophile substituents, these ones here, are pointing downwards or towards the new double bond that gets formed over here, which was the back carbons from the diene. Alright, so that's the endo. Let's take a look at what the exo looks like. And here's the exo. The exo is actually not formed, but this is what it looks like. And let's have a look at the way it forms. See, we've got the two carbons from the dienophile here joining on to the end carbons from the diene, which are here and here. And you'll notice that the difference between exo and endo is that now these groups that were attached to the dienophile are now pointing outwards. This is going to give the exo, which is going to have the substituents on the dienophile pointing away from the new double bond that gets formed. Now the reason this one doesn't get formed is for that reason, is because these groupings here can't interact with the p orbitals that make up the diene because they're pointing outwards. However, let's go back to the endo here. And you can see that the dienophile now can interact with the double bond, the p orbitals from the double bond. So we can get a little bit of interaction going on here between the p orbitals of the dienophile down here and the p orbitals from the diene up here. And that allows for a more favorable product when we're talking about these kinds of Diels-Alder reactions.